Morning, grade sixes. Welcome to your daily lesson of mathematics brought to you by WorksheetCloud. I hope you guys are all well this morning and looking forward to your lesson. Just a reminder of the email address on your screen, grade6@worksheetcloud.com. As always, please feel free to send me any questions, queries, suggestions of work you would like me to go over, and I'll be more than happy to do so for you over the next few lessons. Today we're looking at sequences. It's the second part of our sequence series. Remember, we've got our warm-up and mental maths questions on either side of that main theme, and then our brain bender and challenge to finish off on. So our warm-up for today is a bit of an archaeological theme. So you need to tell me the value of each symbol, and don't forget to tell me the value of the question mark at the end. Take your time, write everything down, and be sure to check your work at the end. I tried this out via trial and error. And the first thing I did was I started on the fourth line, and I thought, okay, well, anything divided by 1 is 1. So I thought maybe this was 1 equals 1 divided by 1. And let's see how that carries on. This means that I have 15 plus 1 on the third line. So that's going to give me 16. I then went and tried out 7 plus 7 is equal to 14 because, you know, it's two equal and identical symbols. And then if I say 7 minus 7, that's obviously going to be 0. So that means that the skull needs to be 14, because 14 minus 14 is also 0. And then if I know that the skull is 14, then the mask has to be 2, because 14 plus 2 is 16, and so is 15 plus 1. So far everything works out quite nicely. And then all that's left is 2 times 2, and that is equal to 4. Okay, so I hope you guys managed to work through that. Let's see how we get on with our mental arithmetic questions today. Okay, so there are your mental arithmetic questions for today. There are 8 of them today. Press pause, take your time, write everything down, check your work methodically, be really careful, and make sure you're confident before you move on to the next question. Right, off you go. Screen, straightforward addition. We've done a few of these, so we just add normally and carry where necessary. Remember the decimals line up. And for me, the most important part is checking, and I check by doing subtraction. So this time I'm going to actually subtract 149,753, and let's have a look if I get 419,473. So 6 minus 3 is 3, so they both match. I can't do 2 minus 5, but I can do 12 minus 5 is 7. And they both match. I need to borrow for the next one. So 11 minus 7 is 4. And they both match. I need to borrow again. 18 minus 9 is 9. And the decimals line up. And again they match. 5 minus 4 is 1. They match. And 5 minus 1 is 4. And they match. So I'm confident I can move on. Everything's correct. And now we can have a look at the subtraction sum in question number 2. So question number 2, 719,01, take away 278,49, and we know that we're going to have to borrow when the numbers are not big enough. So 11 minus 9 is 2, 9 minus 4 is 5, again the decimal lines up, 8 minus 8 is 0, 11 minus 7 is 4, and 6 minus 2 is also 4. So let's go ahead and check. So we do the opposite of subtract, which is add. So 2 and 9 is 11, 5 and 4 is 9, 0 and 8 is 8, 4 and 7 is 11, and 4 and 2 is 6. So I'm confident and I'm happy that I'm correct. So I can now move on to my next question. Question number 3 is starts off as long multiplication, what I'm going to do is I'm going to use a double and half method. So I'm going to double 53 to 106 and half 12 to 6. I'm going to double 106 to 212 and then half 6 to 3. And now I'm just going to say 200 times 3 is 600 plus 12 times 3 is 36. So that's going to give me an answer of 636. Let's have a look if that answer is correct by using another method. And the other method I'm going to use is a compensation method. So I'm first going to say 50 times 12. And I know 5 times 12 is 60. So 50 times 12 must be 600. And then I'm going to go 3 times 12 equals 36. And if I add them together, I get the same answer. So my double and half method that I used originally must be correct. So this can be used called compensation method or the split method. Either way, you've got to do the same thing and you end up getting the same answer. Okay, then we have a short division question and we're dividing by 2. And that's going to be 8,906 divided by 2. And we know that 2 goes into 8 4 times. Decimals line up. 2 goes into 9 4 times. Carry the 1. So that's 2 into 10 goes 5 times. And 2 into 6 goes 3 times. Now to check, I must do multiply. And I can just multiply in a column method to check, as it's short multiplication. And I get 8,906. So happy days, I know I'm correct. The addition of fractions with different denominators is next. So the first thing you guys need to recognize is, well, what is the lowest common denominator of 10 and 3? And yes, that's going to be 30. So 10 goes into 30 3 times. So 3 times 3 is 9. 3 goes into 30 10 times. So 10 times 1 is 10. If I add those together, I get 19 over 30. And that is in its simplest form already. Question 6, we're dividing by 10, and we know that when we divide by multiples of 10, such as 10, 100, or 1,000, then the number gets 1 place smaller if it's 10, 2 places smaller if it's 100, and 3 places smaller if it's 1,000, and so on and so on. So powers of 10, more than multiples of 10, sorry. So if I divide 134,98 by 10, then my number becomes 13,498. Question 7. It'll be interesting to see if you guys pick this one up. 42 divided by b equals 7. So 42 divided by what equals 7? And that's quite correct. B is going to be equal to 6. And then just a conversion question to end off on. 2,5 meters is equal to how many centimeters? And your conversion from meters to centimeters is to multiply by 100. So that's going to be 250 centimeters. Okay, guys, I hope you managed to do those 8 questions. We've done all these lessons before, so if there's something you need to brush up on or consolidate, then go back and have a look at the online lessons with activities and memos and make sure you understand any concept that you're unsure of. We're going to have a look at generating sequences from flowcharts. So what do I mean by a flowchart? Well, here's an example of the flowchart of a flowchart on your screen. So if I asked you to write down 3, add on 1.5, get an answer, write that answer down. Is your answer more than 10? If not, then add on another 1.5, write that answer down. If that answer is more than 10 and the answer is no, then you just add on another 1.5. Then when you get to an answer that's more than 10, you stop. Okay? So an example would be starting with 3, adding on 1.5 to get 4.5. It's less than 10, add on another 1.5, gives you 6. It's less than 10, add on another 1.5, etc., etc., until you get to 10.5, and that's where you stop. So that will be a finite sequence. Okay, it has a definite end. You can also see that this sequence only has 6 terms. So 3 is a term, 4.5 is a term, 6 is a term, all the way to 10.5, and each term is separated by a comma. And as we've already mentioned, this term is finite. Okay, so here's another flow chart. Write down the number 5, subtract 2.1, write down the answer. If your answer is less than -3, if it's not, then you subtract again. If it is less than -3, then stop. Okay, so how would this sequence look? Start at 5, subtract 2.1, get 2.9. Subtract another 2.1, get 0.8. Subtract another 2.1, get -1.3. And subtract another 2.1, get -3.4. -3.4 is less than -3. Remember, the larger the number is with the negative sign in front of it, the smaller the number is. Okay, apologies. So there you can see that, again, it's a finite sequence. It has a definite end. There are 5 terms in the sequence, and they're all separated by a comma. Here's another one for you. If you write down 200 and you divide it by 2, write the answer down. If the answer is less than 7, no, divide by 2 again. If it's if it is less than 7, then stop. So I'm going to give you a few seconds to start writing this down while I'm talking. Remember, you start with 200, your terms are separated by a comma, and it's going to be a finite sequence because it's got a definite end. So by now, I'm sure you've written down the sequence. 200 divided by 2 is 100, divided by 2 is 50, divided by 2 is 25, then 12.5, then 6.25, and 6.25 is less than 7, so that's where you need to end, okay? If you're struggling to divide an odd number by 2, so for example, 25 divided by 2 is 12.5, then just split it up. So 20 divided by 2 is 10, 5 divided by 2 is 2.5, put the numbers together. Divide 12.5 by 2, divide 12 by 2 is 6, a half divided by 2 is a quarter, which is 0.25, put them together, you get 6.25. That's a finite sequence, it's got 6 terms. Let's have another go. So here you're going to write down 3 and 4. You're going to add together the 2 previous numbers. You're going to write down the answer. If the answer is more than 100, then you're going to stop. And if the answer is less than 100, you need to continue until you get to more than 100. So again, I'm going to give you a few seconds to write down the sequence to see if you can generate it, separate it with commas, and let's see how you guys get on. So if you wrote down 3 and 4 and you added them together, you would have got 7. That's less than 100. So you would have continued to add 7 and 4, which gives 11, less than 100. Then 7 and 11 to 18, also less than 100. And you would have continued until you got to 47, add 76. That would have got you 123, and that's where you would have ended. Again, a finite sequence. Looks like there are 9 terms in it, all separated by commas. So this moves us on to predicting terms in a sequence. So usually we can predict terms, or we can predict how a sequence will continue by looking for patterns, okay? And the best way to explain this is to use an example. So here you can see that 87, 84, 81, and 78, it's subtracting 3 each time, okay? So that's a linear sequence because the difference is always the same. So sometimes, however, sequences don't always continue as we would expect. And again, it's best to use an example. So here you got the numbers 1, 2, and 4. So first increasing by 1, then increasing by 2. So it's non-linear. And my question to you is, how could this sequence continue? And you'd be quite correct in saying, well, if it first increases by 1, then increases by 2, then it must increase by 3, and then by 4, and then by 5. Okay? But you need to be able to recognize the patterns within the sequence to continue writing the numbers that follow. So here's some different ways in which the sequence might continue. So first we looked at adding 1, then adding 2, then adding 3, and adding 4, etc., etc. It could have been 1 times 2, then 2 times 2 to get 4, then 4 times 2 to get 8, then 8 times 2 to get 16, and that could have continued. So there we have 2 different ways of continuing a sequence. And we can never really be certain how a sequence will continue unless we're given an exact rule, or we can actually justify the rule from a practical context. So if we were told that the sequence increases by 1 each time, then we can be certain that it would be the top sequence. Or if we were told that the sequence doubles, the terms double each time, then we can be sure of the second one. If not, and they asked us to complete the sequence, then we would have to justify the reasons behind choosing each sequence. And if your justification or your proof was correct, then your answer is definitely going to be correct. So just make sure you can always explain why a sequence follows the order or the pattern that you think it should, and make sure you can prove your answer. So here's a sequence that increases by 3 each time. And there we can just say that the rule from getting from one term to the next is add 3 or plus 3. Okay? Now this is called a term-to-term rule, because from the first term 1 to the second term 2, we're adding 3. Okay? From the second term 4 to the third term, which is 7, we are adding 3. So from each term to the next term, so between consecutive terms, we're adding 3. That's called the term-to-term rule. So the term-to-term rule for that sequence is plus 3. All right, so quite a nice, easy one for you guys to get your head around. So does the rule plus 3 always produce the same sequence? So the answer there would be no, because it depends on what number you start with. So if I started with 2, then my sequence is going to look like the one on your screen at the moment. But if I started with 0.4, excuse me, then my sequence would look like the second sequence on your screen. So I could have put infinite number of numbers to start with and then add 3. They would have all looked different. Okay, so just be aware that the rule add 3 doesn't always produce the same sequence of numbers. A term-to-term rule gives a rule for finding each term of a sequence from the previous term or terms. Quite a mouthful, but we must always be given the first number in the sequence. Okay, we cannot be told create a sequence where you add 3 and we don't get given a starting point. Okay, we have to be given a starting point unless the instruction is create your own sequence using a term-to-term rule of plus 3 or whatever they give you, whatever rule they give you to use. Okay, so if I, for example, give you a first term of 5 and my term-to-term rule stated add consecutive even numbers starting with 2, okay, then that would give us a sequence of 5 add 2 is 7, okay, and then we need to add consecutive even numbers starting with 2, and then you add 4, then you add 6, then you add 8, then you add 10, and you would continue you would continue going on by adding an extra 2 each time. Okay, so consecutive even numbers are the numbers in red. Okay, so 2, 4, 6, 8, 10, 12, they are all even numbers, and they are consecutive even numbers because those are the ones that come in order. Okay, if we gave you, so if you write the first 5 terms of each sequence, given the first term and the term-to-term rule, let's see what you guys come up with. So if my first term's 10 and I add 3, then yes, it would be 10, add 3 to 13, add to 16, add to 19, etc., etc. If I gave you the first term of 100 and I asked you to subtract 5, then it's going to look like that, multiples of 5 but going down. If I gave you 3 and our term-to-term rule was to double it, then you'd double 3 to 6, double 6 to 12, then double 12 to 24, and so on. If the first term was 5 and you multiplied by 10, then your answer would be the sequence of 5, 50, 500, 5,000, 50,000. For 7, if I asked you to subtract 2, start at 7 and subtract 2 each time, and you would go down to -1. And you can also use decimals in term-to-term rules, and that's going to give you the sequence of 0.8 all the way up to 1.2. So that's just to highlight what the term-to-term rule is, but it's really important that you understand and know what the first term is and where to start. Sometimes we can put sequences in a table, and quite often it actually makes it a lot more understandable to us. So we can visualize, okay, in the first position we might have the term 3, in the second position the term 6, in the third position the term 9, and it would continue until you were told where to end, or it's actually an infinite sequence. Okay, and you can see there we're adding 3 each time, or it might be multiples of 3, and then we get to something called the nth term. Okay, but before I explain that, as I've already discussed, we can say that each term can be found by multiplying the position of the term by 3. So what do we mean by that? Well, if you look at the first position, it's 1, and 1 times 3 gives you term 3. If you look at the second position, it's 2, and 2 times 3 gives you 6. If you look at the third position, it's 3, and 3 times 3 is 9. And that goes all the way up to the sixth position, where 6 times 3 is 18. So that's another way of looking at the sequence, and that's called the position to term rule. So remember, we had term to term. So the term to term rule here would be to add 3. But the position to term rule would be to multiply by 3. Now, we say that the nth term is 3n. So what that means is any position, okay, is actually called n, all right? And for me to get from the position to the term, I need to multiply n by 3. So that's where we get 3n, because 3n means 3 multiplied by n. Now, I know that's an algebraic term, but I just wanted to touch on it so that when you do encounter this in grade 7 and 8, you might have a little bit of an inclination to, oh, I remember doing that with WorksheetCloud.com. Let's see if I can have a go and be confident in figuring out what that nth term is. Now, the nth term is used for, if I had to say to you guys, what is the 100th term in this particular sequence? You're not going to want to go write out 100 terms, because that's going to take you forever. So to know the nth term, so if I put 100 in place of where n is, all I then need to do is go, okay, 100 times 3 is 300, so the 100th term is going to be 300. And that's really, really useful for you moving forward. Okay, and as I've explained, the 100th term would then be 300. Guys, thanks very much. Go over those sequences again. It's really important that you understand, what all that theory is, and what all those terms and descriptions, term-to-term rule, position-to-term rule, what is a term, what is a finite, infinite sequence. Just be confident that you know that moving forward. Sequences are gonna be around for a long time in your school mathematics career. So you'll go over it again. Have a look at the online activity and memo that accompanies this lesson, just to consolidate and make sure you fully understand the concepts that we've spoken about today. And remember to send me an email at grade6@worksheetcloud.com if you're unsure of anything I've covered, and I will try and go over it again in the next couple of lessons, either as a starter or just a brief explanation if you're unsure of anything. So here's our game of 24 for today, and this is what we're finishing off on. Come up with an answer of 24 for each card using add, subtract, multiply, or divide, or you can use a combination of them. It's up to you, and see how many different ways you can come up with the answer of 24. You should get 3 different ways as a minimum, but perhaps there's more, and you'll challenge each other at home to make it a little bit more exciting. Grade sixes, thanks for tuning in and watching today. I hope you guys have a really cool day further and a great week ahead. I really look forward to catching up with you next time. All the best.